Okay, so previously we talked about the intro to chromatography. What does the actual word mean? And we said that chromatography means separation. That's all that it means. Can things separate? Yes or no? And if so, how can we improve that separation? All right. So today's video, or this video that you're watching now, is going to concern a little bit of history when it concerns chromatography. Okay. So back in the early 1900s is when chromatography first began. And the man that kind of started the chromatography world, his last name was Tisvet. T-S-W-E-T-T. Mikhail Tisvet, but we really spell it like Michael. Okay, so Michael Tisvet, Mikhail Tisvet, I don't really care what you say or what you do. That's not important. But what is important is that this is the person that started the world of chromatography for us that we kind of know and use today. Now, Michael Tisvet really wasn't a chemist at all. He was actually a botanist. And this botanist made a major play in the chemical laboratory world. And basically what he did is that he went through and he knew that plants had color, right? And most of those plants were green. And he really wanted to focus on chlorophyll. All right, or plant pigments. But chlorophyll is basically going to be the biggest one. And we wanted to know, how can we take these pigments and separate them? Because maybe we need to start taking a look at these different colors to see why they're there and what is present and what is absent. And maybe the chlorophyll especially. What can we go through and take a look at? Yeah, chlorophyll spelled wrong, so don't pay attention to that. Okay, so Mikhail Tisvet basically went into a laboratory one day and he said, well, I probably can do a simple procedure in order to separate out these pigmentations for me. So what he did is that he took a sample, and this sample was basically blended into a lab, right? So he blended it in the laboratory and he made a mush out of it. And he added plain old Jane alcohol. All right, this is going to be ethanol for us, ETOH. And that ethanol is going to provide a solvent that will start extracting out all of the pigments for us. So the alcohol performed the extraction. And this alcohol solution basically contained all of the pigments that were inside of that mush that Michael Tisvet created. Now, these pigments are going to be more than one thing. We're going to see basically a green color in a way, right? We're going to see some type of green color that's going to form, and this green color or this green blob is actually made up of more than one color. So what's inside of here could be a little bit of blue as well, right? Some blue, and we could maybe have some red in this color or in this pigment, and we could also maybe have some orange into the pigment, but basically it was a soup of colors. And he scratched his head for a minute and he said, okay, now that I've extracted this pigment, now that I've extracted all of these colors, how can I separate the colors from each other? Right? That was the big problem. How can we take this alphabet soup and how can we separate all of the letters from each other in the alphabet soup very easily? That's what he wanted to do. It needed to be somewhat automated. It needed to be user-friendly. It needed to be something that maybe could be done pretty quickly. So he said, okay, well, maybe alcohol isn't the best color, okay, or the best solvent for the colors. So maybe I need to try something else. So he went back to the drawing board, and if this was round 2, he did the same thing, or round 1, he did the same thing in round 2. And he chose something else. And this other solution, or this other solvent, was petroleum ether. And petroleum ether is not as polar as an alcohol would be, right? So this is not as polar as the ethanol. The ethanol up here was a little polar on us, okay? So this goes back to the whole basics of what is polarity and what's non-polarity. So with the petroleum ether, it also took out some of the color, okay? So some of the color got taken out, but not all of the color got taken out with the petroleum ether. So if we had the alphabet soup here, this one was missing some letters. So not everything pulled out. And that's pretty important because Michael Tisfit knew at this time that basically we could play off of the solvent, and the solvent interacted with these molecules in some form or some fashion, and it had an attractiveness to it, right? Some of them were attracted to others, and it looked like alcohol did a very good job to remove everything. Petroleum ether, well, it really didn't do a very good job pulling all of the pigmentation out of the plant. So no one really knew why at this time that this began to happen. So he scratched his head again, and he said, okay, well, there's got to be something here that we can do. And what he decided to do is to take this whole concept of using a solvent, and with the concept of a solvent, go and actually begin to try to automatically separate these components. So he said, okay, well, maybe, just maybe, what I could do is I could go into a laboratory and take this big, tall piece of glass tubing. And this glass tubing is very similar to a burette that you might have used in the laboratory up to this point, just without the markings. And down here at the bottom, we would have a tapered end with a stopcock on it that allowed me to control the flow. And inside of that glass tubing, we would put some kind of inert, non-reactive material. All right? So we're going to fill it full. And we're going to fill it full of this solution, or this solid, really. And this solid should be slightly inert, meaning it shouldn't really react with things. It shouldn't change the chemical compositions of things, right? It should just provide a buffer, some kind of room, some kind of hurdle or obstacle for these molecules to go over. And this solid stuff back in Michael Tisfit's day was calcium carbonate. And calcium carbonate, of course, is known as AKA chalk. That's all that it was. He took chalk and he grounded it up and he turned it into a very fine powder. And that chalk was basically dumped into this really tall piece of glass tubing. And he kind of packed it down to make it tight. And this was very inert. It shouldn't have reacted with the colors. It shouldn't have made the colors turn into a different molecule. No reactions were going to go on. But this was a very kind of stationary solid that was in place. And then what he did is that he took this sample with all of these colors and he put some of that sample on the top of the chalk layer. And in the beginning, it just kind of seeped down into the top layer of the chalk. That's basically all that it did, right? So he said, well, I've got to be able to push this sample through. I've got to be able to take the sample at the top of this column that I have made, this column of chalk, and I've got to be able to push it through the column and out the other end. So in order to do that, I need a liquid. And he said, well, you know, I used alcohol here, right? I used alcohol to extract the colors. So I'm going to put alcohol into the top, and I'm just going to keep putting alcohol there. And that alcohol can keep pushing my colors, the pigmentation, through the column. So as the alcohol dribbles and drips through this column, and it goes through and it comes out the other end, and it drip, 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 it is pushing the molecule or the sample through as well. All right, so what he began to see is that over time, the colors began to separate. So maybe a red band showed up, and all of the red pigmentation kind of stuck together, and it flowed through this column that he had just made. And then maybe he saw a blue band that maybe traveled a little bit quicker, and the blue band travels through the column, but are all staying together. And then finally the orange column, maybe the orange color that's in that pigment, it traveled even faster through this column, and it goes out the other end. And he said, Eureka! I've been able to separate components from each other. And I can visually see that because I see the colors. And this is where chromatography first begins to happen. So he takes this concept and he says, if we can do this with pigmentation, we can do this with other molecules as well. It doesn't just have to be color, but color is basically how this thing got started. All right? So Michael Tisvet was able to take alphabet soup, or pigmentation from his plants, and he began to separate the letters from each other automatically, just by pouring the soup through this tall glass column filled with chalk. All of our letters began to separate. In his case, all of the colors began to separate. So this is what started the field of calcium carbonate. All right? So kind of what he did, if you want to take a look at maybe a picture of something that's very similar, this is what he did on a small scale. So instead of a huge big glass tubing piece here, we are using just a pasteur pipette. A glass pipette that's basically tapered here at the very end that you've used in our laboratory before as dropper pipettes, right? And then inside of this pipette, or in Tisvet's case, his glass column, we can put some kind of inert material. And in his case, it's chalk. But in our case, we don't use chalk anymore. What we now use is another substance that's still inert, but it's a little bit better at doing the separation job. Chalk is cheap, right? And it does what it needs to do. But there's a better alternative version out there that we now use constantly in a laboratory. And he put his green pigment up here at the very top, and this pigment began to separate depending on what kind of sample he crushed up. And it looks like in this sample, we had a yellow color to come out of the burette tip. And then it looks like a green color is now coming out of the burette tip. So he was able to physically see the colors as they separated in the column, and he was able to physically put a collection container up underneath that column and collect the colors as they come out one by one. And this is the birth of the chromatography field. Okay, so in the next video, we'll pick up from here, and we'll talk more detail about chromatography and about this whole separation process that begins to happen in a laboratory. So stay tuned. Don't take too long of a break. You're on a roll. You can do this. I know you can. So come back and we'll talk a little bit more.